difficult problems which can be asked in the NEET examination generally. Let us see the first problem. It is based on the concept of self and mutual induction. So the problem is like this. An EMF of 5 volt produced by the self induction when current changes at a steady rate from 3 ampere to 2 ampere is 0.1 millisecond. The value of the self-induction is, the options are A, 0, B, 5 millihenry, 500, C, 505 millihenry, 5000 henry, and D, 5 millihenry. What is the question? That is an EMF of 5 volt produced by a self-inductor when current changes at a steady rate. So hereby the values of current changes from 3 ampere to 2 ampere and the EMF is 5 volt. Hence the value of EMF is 5 volt. The current changes from 5 ampere to 3 ampere. 3 ampere to 2 ampere. In this way, so we can solve this problem using the formula L is equal to E upon di by dt. So let us put the values here. So the value of EMF is 5 volt and the current changes from 3 ampere to 2 ampere divided by the time is given here 1 millisecond. It is 1 milli means 10 to the power minus 3. So in this way, this 3 minus 2 is 1, and in this way that once one go there, so we are finally getting it is 5 millihenry. In this way, the answer to this question is 5 millihenry, which is correct. Second thing is that the second question, a coil L is equal to 5 henry, current changes. See here, the second problem is like this. In a coil of value 5 henry, the current changes at the rate of 2 ampere per second, at the rate of 2 ampere per second, then the EMF induced will be how much? Then the EMF induced will be dash dash. So the options are here. It is 10 volt, it is minus 10 volt, it is 100 volt, and minus 100 volt. Such options are there. So how, see, taking into consideration the same thing, same formula used for self-induction, mutual induction, we are going to apply the same formula here. E is equal to d phi by dt. So E is equal to minus L into di by dt. So EMF, we are interested to calculate EMF, hence E is equal to the value of this inductance is 5, so minus 5 into at the rate changes at the rate of 2 ampere per second, hence the current is 2. Then the induced EMF he is asking. So it is 5 to the 10. So E is equal to minus 10 volt. In this way, we are getting this answer B is correct here. So this is about the second question. Let us proceed to the third question here. So the next question in front of you is like this. The current passing through a choke coil of 5 Henry, the current passing through a choke coil is 5 Henry is decreasing at the rate of 2 ampere per second, is decreasing at the rate of 2 ampere per second. The EMF developed across the coil is, the EMF developed across the coil is dash. So again we have to find the EMF of the coil. The options are given here again, saying 10 volt, B minus 10 volt, C 2.5 volt, and D minus 2.5 volt. So dear students, let us see here. Anyhow, we are talking about the self and mutual induction, and we are conducting the practice of the same numericals here. So the same formula will be repeated here. So hereby we are interested to find the EMF whose absolute value will be equal to L into Di by dt. So it is 5 Henry, it is already given here. L is 5 Henry, and the rate of change of current is 2 ampere per second. So in this way, the answer to this question is 10 volt. So which one is correct? Option A is correct here. So in this way, this is about the third question. So let us go ahead and see the next type of question here. If a current of 10 ampere flows in 1 second, the question is like this. If a current of 1 ampere flows in 1 second through a coil and the EMF induced is 10 volt, through a coil and the EMF induced is how much? It is 10 volt, is 10 volt, comma, then the self inductance of the coil is, then the self inductor or inductance of the coil is dash. So same formula we have to use, because just few values are given and few values are asked here. So again here 2 by 5 Henry, 4 by 5 Henry are the options. The next option is 5 by 4 Henry, and the last one is 1 Henry. Which one is correct? Yes. Can you guess? This one? No. See here, the solution, we are using the same thing here. What is that? That is absolute value of EMF is equal to L into Di by dt. But here by now we are interested to find L. So L will be equal to as mod E divided by Di by dt. So L is equal to, the value of EMF is 10 volt, it is given, whereas if a current of 1 ampere flows in 1 second, so this value is 1, so inductor is 1 Henry. So the B option is correct in this case. So in this way, we are going ahead one by one. Let us go to the next problem. Which number? Fifth number problem is like this. Here, a 100 millihenry coil carries a current of 1 ampere. A 100 millihenry coil carries a current of 1 ampere. Energy stored in its magnetic field is energy stored in this magnetic field is dash dash. The options are given here. 1 joule, 0.05 joule, 0.5 joule. It is 1 joule. B 0.05 joule, C 0.5 joule, and D it is 0.1 joule. Solution to this problem is like this. Again we are using E is equal to 1 by 2 Li square. Energy stored can be calculated by 1 by 2 L into I square. So putting the values, see here, 1 by 2 into the value of inductor is 100 milliliters 10 to the power 3. So in Henry it can be written as 0.1 divided, and the square of the current, that is 1 ampere current, is there. Square is also 1. So 0.1 divided by 2, that is nothing but 0.05 joule. So which answer is correct? Answer C is correct in this case. So this is about the different problems based on self and mutual induction. Come on, the next problem is like this. A varying current in a coil changes from 10 ampere to 0 in 0.5 seconds. A varying current in a coil changes from 10 ampere to 0 in 0.5 seconds. If the average EMF in 0.5 seconds, if the average EMF induced in the coil is 220 volt, induced in the coil is 220 volts, then the self-inductance of the coil will be dash dash. Then the self-inductance of the coil will be dash. The options are given here. Option A is 5 Henry, 10 Henry, 11 Henry, 5 Henry, B is 10 Henry, C is 11 Henry, and the last option is 22 Henry. So what should be the correct answer? You can guess. What is the current? The question. A varying current changes. It changes. The varying current in a coil changes from 10 ampere to 0 in 0.5 seconds. If the average EMF induced in the coil is 220 volts, then the self-inductance will be dash dash. So again we have to use the same formula, that E is equal to L into di by dt. So see here, solution to this problem is like this. The absolute value of E is L into di by dt. So from this we can get the values. Current changes from 10 ampere to 0, means the value of di is here. 220 volt value of EMF is here. So in this way, L is equal to absolute E divided by di by dt. So this value of L can be calculated as E is equal to 220 volt is given here divided by value of I changes, that is from 10 to 0, 10 to minus 0, and in 0.5 second time is given 0.5 seconds. Means 10 divided by 0.5 means again 25. 220 divided by that much means we are getting here 11 Henry. L is equal to 11 Henry. Are you getting me here? This 10 minus 0 is 10 divided by 1 by 2 means again this 2 goes there and divided by 2 means 11 Henry. So which option is correct? Option C is correct. Now the last question based on this particular concept, it is self and mutual inductance, is coming to you. That is a current of 3 ampere in a coil causes a flux in the second coil. A current of 3 ampere in a coil causes a flux in one coil, causes a flux in the second coil. Of 200 turns, of 2000 turns. To change by 6 into 10 to minus 4 Weber, to change into 6 into 10 to minus 4 Weber per turn of the second coil. Weber per turn of the second coil. Yes. The mutual inductance of the pair of the coil is, yes, the mutual inductance of the pair of the coil is dash dash. So are you getting here? There is a pair of coil. In one coil, a current of 3 ampere in one coil causes a flux in the second coil of 2000 turns. To change it into 6 into 10 to minus 4 Weber per turn of the second coil, the mutual inductance of the pair will be how much? The options are here. Yes, one of the option is 6 Henry, 2 Henry, 0.4 Henry, 6 Henry, 2 Henry, 0.4 Henry, and last one is 4 Henry. So in this way, again my dear students, we have to use the same formula as we are dealing with the numericals depending upon the self and mutual inductance. Therefore, here we are using the formula Lm is equal to mu r into La. Mu r into A. So La, it is 100 into 0.05 because it is changes like that. So hereby we have to use the mutual inductance of the second, means flux in the second, number of flux in the second coil is equal to M into I. That we have to also use here. So M is equal to N5 by S. So in this way, that is 2000 into 6 into 10 raised to minus 4 divided by the secondary current changes is 2 ampere. So by simplification we will get the answer as 0.4 Henry. So answer D is correct here. So that's all about the numerical practice on this self and mutual induction. Thank you very much.